Hey guys, I know I'd go live about 10, but I've got somewhere to be, so I'm just giving you this video until I come back and load up just another video for you. This is sort of supporting evidence to the video that's going to follow this. I'm going to show why this is shear, but from column 12. Let's go first to the drawings. And this is the back end of what we're looking at, that collapse. And this is where they're claiming that shear can happen from sliding. I'm saying it's the dead weight of the column that's the column and is supporting loads from the canopy. Created this shear cracking here. Now, importantly, to support part of my rotation at the top of the pier coming inwards towards number 2, if you will. So this is 12 going in towards 2 or towards number 1. Some type of tilting action, leaning action inwards. We have 2-inch spacing here between the bottom of this is the blister bar. See that shape, if you will? That correlates to this member here, this concrete member here sticking out, which looks like this member here sticking out in this shape here. And if I could show you another way, I would. I mean, I can show you another way, but let's just go on from there. So what's important about it? Remember I just said 2 inches? Let's look at the purchase of the SHIMS. The SHIMS were purchased by MCM. See, it says SHIMS right here. 4 of them. We know there's 4 on top of there, so we're going to use these 4. And that's 2.5 inches right here. 2.5 inches plus 1/8 of an inch right here. So it appears that maybe they could double stack them. We did not see double stacked. So let's just go with 2.5 inches, 2 1/2 inch on 4 of the SHIMS, $1,300. And 2.5 inches is what this is supposed to be sitting on. If I have this correctly, if you would have measured under there, we'd have got a different number. But we're looking at 3 and let's call it 3 3/8. This explains why when we look at the images here, why it appears higher, as I keep telling you, it appears higher because this is leaning in. And when it leans in, the back end of it comes up and gives you this higher reveal. So if I'm correct, this is about 2 3/8, 2.5 inches on the ends. And again, this is higher than there because we're leaning. It's shearing down and being pulled back by the tension, I believe, in the canopy from the longitudinal cables. This is close to 5 inches, so we're about 1.5 inches of a radius from the bottom end leaning backwards, and that explains why it will explain a lot more cracking details here. One crack it doesn't really quite explain for me, but I'm still working on that. But again, that explains why it would be high here and the shape we're looking at. Let me get you that right here. So this is approximately 5/8 of an inch, and if we could move this down further, it would be even greater in height, and that would explain why. Let's go with that's 5/8. Now this was just here. Now it's here. Now it's about 1/4 inch, or is that 1/8? But now we see it's wider here. So it was in this crack. Now they moved it to this one, and there's your measurement. You can see it's narrower here, getting wider as we go away, and higher. So how do you get that with the shear if it's falling down? You'd have to have, again, the tilting action of it coming back towards us, and that would be the canopy, in my opinion, pulling and causing a rotation towards us, towards the number 1 or number 2. This would explain a lot of the tension cracks that I observed. I wanted to give you that real fast and jet out of here. Hopefully that works for you guys for a little sampler.